Takes a union break every now and then. Okay. Let's see. Where's a nice one? So let me first capture the idea real quick, the same way that it's normally done. I like that word exact. It kind of tells me that it's exactly the derivative of some function. Right? Here's f, and I took the derivative, and I made a diff q out of it. So this is exactly coming from an f. I mean, that's sort of the way I kind of remember that. And this is just checking. So m I would assume is fx. If I check fxy versus fyx, and they're equal to each other, then it's exact. There should be an f. I should be able to figure out what f was. Okay, so let's look at this here. Let's see. What do you got, Jeff? Did you actually do one, Jeff? No, I guess I should pick one out now. Here we go. Oh, let's see. Let's start one that's not too freaky. Yeah, okay, that's good. Do notice that this requires this to be 0 to work correctly, because it's assuming it came from f equal a constant. Right? All right, so how do you check to make sure that it's exact? Yeah, what's this partial y of this? This is your m, so what would my be? Please, I'm going to start yelling. It's been a long day. And then you check that against nx. And real quick, you guys can see how to remember this, right? Sorry, dx, so I've got to check it dy. I've got to do the other one. Nx is going to be what? 3y squared. So check, it is. Now, you might be able to imagine. I don't know if I want to focus on this or not. I can't remember if I assigned a homework problem with this. If it wasn't exact, there might be an integrating factor I could figure out. Oh, shit. Let's not go there yet. Right? But you might be able to realize that the idea of an integrating factor might be more generally applicable. Right? And certainly, and there actually is. There's a way you can figure out a form of an integrating factor to make this true if it currently isn't. Or at least try to see if there's a way to make that happen. Okay. So now watch. This, then, since this is true, this must be fx. There's no question about it, right? And at the same time, this must be fy. So what's really cool is you can integrate this with respect to x to at least get a form of f. Why can't you get the full answer of f from just one piece of information? Because there's going to be a plus a constant. But what's a constant according to this? Any function of y. Oh, shit. So when you integrate this, you're not going to put plus c. You're going to put plus g of y. That's a constant according to this guy. So what do you get when you integrate this? You get integrate x cubed. Good. 1/4 x to the 4. Now be careful now. Good. Plus g of y. I love it. Now you got to do this a few times to get the process down, but this is a remarkably beautiful, just, you can sink your teeth into this process, which you can't always do with all kinds of math. I know what fy is supposed to be, so let me do, and I know what f is supposed to look like, so let me make fy off of this and compare it to what it's supposed to be. So what's fy according to what I have here? You do it? 3xy squared plus, this is a function of y, so I'm doing fy, so it's just going to be g prime of y. And that equals That's Fy, that's from the form I've just created, and that's what it's supposed to be. So what's G prime of Y got to be?
0.
Good. So what's G of Y got to be? Constant. Is that always going to be 0? No, it isn't. It's not always going to be 0. Whatever it is, I would integrate it. Here it was 0, so that I get constant. So here's my answer. I really want you to understand. That is my answer, except I didn't know what the shit that was, but now I do know what it is. It's just a C. Is it always going to be just a C? No, it depends on what this is. If there was some other function of y floating around here, that would have been equal to this, and I would have had to integrate it. Here it was just 0. There was no other function of y there. So then what's the f? What's the f? Shit. It's going to be 1/4 x to the 4th plus xy cubed plus a constant, right, equals a constant. So you just kind of suck all the constants together. That is the solution. Or little 4s. Sorry, 4. All right, so again, and again, this happens on. It happens if you take linear or diff Q. Anybody already taken linear? I think I might have asked this already. There's going to be several things in here. You're going to be like, oh yeah, that's this, and everybody else is going to be like, shut the hell up. And if you do it the other way, in linear, if you take diff Q first, you'll be like, oh yeah, that's this, and everybody else shut up. So Calc 3 kind of does this too. If you've taken Calc 3, this has got to be easy for you. This has got to be, no question. If you haven't taken Calc 3, you're like, no, not yet. But does it make some sense? I mean, you can start to see it's a process you follow. The process doesn't really change. If you do the check and it works, you're guaranteed that this is going to work. You're guaranteed that f exists. It's kind of crazy. Yes, ma'am?
Did you choose to work backwards from the partial of x because it had more terms?
Not really. It just was here and I did it. I mean, I could have integrated here. And it would have been, if I integrate here, it would be xy cubed plus g of x. I would have done everything. It doesn't really matter which one you do first. It really doesn't. But yeah, I like that. I mean, that might be a reason why you want to do one over the other one, because there's more terms. Take care of that part first, so you don't have too many freaky things that relate to this term. Sure, I could see that. Okay. So we just did section 2.4. I don't think I've only got up to 2.2, I think, posted, so I'll post some more. I've noticed not a lot of people have made it to 2.2 yet, so I wasn't feeling too rushed. So I'll get 2.3 and 2.4 put up on WebAssign tonight. So if you want to, you can jump into those. Cool. So quiz on Monday. Section 2.1, that phase portrait stuff. Right? And I'm not going to make you do a field by hand, don't worry. Section 2.2 is the separable equations. So that quiz shouldn't be too evil. Cool. Yeah, that's good. Thanks, man.